All right, we're live. Day 3 of my live coding adventure. All right. Yesterday when I was doing this, I ended up with my ADSR envelopes. So today I thought I'd make use of them by trying to craft a melody out of them. Given that it's the 4th of July, I'll try to do the Star-Spangled Banner, and we'll see how that goes. Basic note. Now, up until now, I've sort of been programming in all my pitches manually. So the next step that we're going to need to do here is sort of set up a standard musical scale so that it's a little easier to work with. I'm going to try to do this using Python 3's dictionary object. The basic idea here is, an octave doubles the frequency. And with an equal temperament, you basically divvy up the frequency into 12 semitones. So each semitone is 1/12 of the way from the octave. But you're not, going up in linear steps. You're basically doing exponential steps. So each semitone in a musical scale is approximately the 12th root of 2. And I say approximately because you know how yesterday I was talking about a perfect fifth being 3/2, a perfect fourth being 4/3. Well, if I do an equal temperament tuning like this, those notes are actually going to be slightly out of pitch. And it's kind of one of the, trade-offs that you have to make with, tuning a piano, because you've got so many notes that you want to play. You can't have all of them be perfectly in tune with one another because it's just not going to work out that way. So equal temperament is sort of a way of getting as close to 12 good workable notes in a scale as we can possibly do it. For comparison, I said a perfect fifth was 3/2. In equal temperament, a tuning of a fifth is 1.4983. So it's not quite exactly 3/2, but it's close enough that it'll work. Likewise, a fourth from A would be D. That's approximately 4/3. So even though those aren't the exact ratios that I was using in my chords yesterday, they're still pretty close to what I actually want. Let's start creating a melody here. The timbre is going to be basically my bass sound, which in this case, I'm going to try to use that square wave that I've been working with earlier. And I'm going to scale it by the pitch so that it matches the frequency that I want. And then I've got my envelope, and my envelope's going to take my start time and the length of the note. And those are the components of my basic note. So let's see if that works. So my original pitch was an A. My new pitch is a C. E. And now basically I can simplify things a little bit. There we go. So basically what I did was this function new note returns a function that describes the context of the note, and then my add functions here takes two notes and adds them together, And then once I've added those two functions together, I play the combined sequence of those two notes together. So now all I have to do is create a whole list of these things and concatenate them together. And I'm well on my way to composing music here. Okay. No, something didn't work there. Oh, I probably need to set the total duration. All right. Well, now I can just list the notes and their lengths. Hopefully this will speed the process up a little bit here. Well, happy 4th of July. I think I'm going to call it a night there. And tomorrow I'll try and figure out a way to get this to play in real time and not take 10 minutes to compose an audio file. So thanks for watching, and tune in next time. Bye.